Hey everyone, welcome back to our channel The Quantum Quest. In today's video, we are going to start vector differentiation. When we usually think about differentiation, we usually think about functions. But what happens when we differentiate a vector? A vector, as you know, has both magnitude and direction. So when a vector changes, we are not just tracking how big it gets, we are also tracking in which way it points. In physics, this is crucial. Think about a moving particle. Its position changes over time, not just in distance but also in direction. By differentiating position vector with respect to time, we get velocity vector, which tells us how fast and in which direction the particle moves at an instant. In this video and in the coming videos, we will explore how to differentiate a vector and understand their geometric meaning. So let's get started. Consider a moving particle. Initially it is at point P at time t. Its position vector is r vector. Now after a time delta t, it has reached point Q. Its position vector is r vector plus delta r vector. Now PQ vector is OQ vector minus OP vector. What is OQ vector? OQ vector is r vector plus delta r vector minus OP vector is r vector. So PQ vector is delta r vector. Now delta r vector by delta t is also a vector. Now as delta t tends to 0, limit delta t tends to 0, this will be equal to dr vector by dt. As limit delta t tends to 0, q tends to p, and this chord will be the tangent across the tangent passing through the point P. dr vector by dt is a vector in the direction of tangent at P. dr vector by dt is also called the differential coefficient of r vector with respect to time t. Now when you differentiate this, dr vector by dt is actually called the velocity vector of this particle, of this moving particle. Now when you differentiate this dr vector by dt again with respect to time, you will get acceleration. That is d square r vector by dt square is equal to acceleration vector at point P. Now we can learn some important formulas. Our first formula is d by dt of f vector plus g vector equals df vector by dt plus dg vector by dt. Now our second formula is d by dt of f vector times phi, where phi is some scalar function, equals df vector by dt phi plus f vector d phi by dt. Now third formula is d by dt of f vector dotted with g vector equals f vector dot dg vector by dt plus df vector by dt dot g vector. Now fourth formula is d by dt of f vector cross g vector equals f vector cross dg vector by dt plus df vector by dt cross g. Fifth formula is d by dt of box ABC equals box of dA vector by dt b vector c vector plus box A vector dB vector by dt c vector plus box A vector b vector dc vector by dt. Now last formula is d by dt of A vector cross b vector cross c vector equals dA vector by dt cross b vector cross c vector plus a vector cross db vector by dt cross c vector plus a vector cross b vector cross dc vector by dt. Let's solve some example questions. Our first example question is, a particle moves along the curve r vector is equal to t cube minus 4t I cap plus t square plus 4t j cap plus 8t square minus 3t cube k cap, where t is time. Find the magnitude of the tangential component of its acceleration at t is equal to 2. So first we have to find the velocity vector. The velocity vector, why we find the velocity vector? Because it is always tangential in direction to the location of the particle at that particular curve. So first we have to find the velocity vector. Now then we have to find the unit velocity vector and dot it with the acceleration vector at time t is equal to 2. So let's start. First we have to find the velocity vector. Velocity vector is dr vector by dt. This is equal to 3t square minus 4 I cap plus 2t plus 4 j cap plus 16t minus 9t square k cap. Now this is the velocity vector. When you differentiate this r vector, you will get this velocity vector. Now we have to find the velocity vector at time t is equal to 2. So velocity vector at time t is equal to 2 is 3 into 2 square minus 4 I cap plus 2 into 2 plus 4 j cap plus 16 into 2 minus 9 into 2 square is 4. 9 into 4 k cap. Now this is equal to 3 into 2 square is 4. So 3 into 4 is 12. 12 minus 4 is 8. 8 I cap plus 2 into 2 is 4. 4 plus 4 is 8. 8 j cap plus 16 into 2 is 32. 32 minus 9 into 4 is 36. 32 minus 36 is minus 4 k cap. So the answer is 8 I cap plus 8 j cap minus 4 k cap. This is the velocity vector at time t is equal to 2. Now we have to find the unit velocity vector. So the unit velocity vector at time t equals 2 is v vector divided by its magnitude. So the magnitude is 1 by magnitude is square root of 8 square plus 8 square plus minus 4 square. This minus 4 the whole square. This into 8 I cap plus 8 j cap minus 4 k cap. This is the unit velocity vector. So when we simplify this, you will get, now 8 square plus 8 square plus minus 4 the whole square is 144. Now the square root of 144 gives 12. So the velocity vector, unit velocity vector v cap is 8 by 12. V cap is 8 by 12 I cap plus 8 by 12 j cap minus 4 by 12 k cap. Now when you reduce this, you will get 2 by 3 I cap plus 2 by 3 j cap minus 1 by 3 k cap. Now to find acceleration vector, we have to, this is a velocity vector. We solved it before. Now we have to find the acceleration vector. So to find acceleration vector, we should differentiate this velocity vector with respect to time. So dv vector by dt is equal to 6t I cap plus 2 j cap plus 16 minus 18t k cap. Now we have, this is our acceleration vector. Now we have to find the acceleration vector at time t is equal to 2. So this is equal to 6 into 2 is 12, 12 I cap plus 2 j cap plus 16 minus 18t is minus 20 k cap. Now we have to dot this acceleration vector with v cap. So acceleration vector dot v cap is 2 by 3 into 12, 2 by 3 into 12 plus 2 by 3 into 2 plus minus 20 into minus 1 by 3, minus 20 into minus 1 by 3. This is equal to 24 plus, all the denominators are same, so this is equal to 24 plus 4 plus 20 by 3. Now 24 plus, this is 24, 24 plus 24 is 48. So 48 divided by 3 is 16. So this is the answer. This is the tangential component of acceleration vector at time t is equal to 2. Next question is, at any point of the curve x is equal to 3 cos t, y is equal to 3 sin t and z is equal to 4t, find tangent vector. Then we have to find the unit tangent vector. So first we have to find the r vector. R vector equals xi cap plus yj cap plus zk cap. Then we have to differentiate it. Then we will, with respect to time, then we will get the tangent vector, which is t vector. Now when you divide this t vector by its magnitude, you will get the unit tangent vector. So let's start. So our r vector equals xi cap plus yj cap plus zk cap. Now r vector is equal to 3 cos t I cap plus 3 sin t j cap plus 4t k cap. Now we have to find the tangent vector. So our tangent vector is t vector equals dr vector by dt, which is equal to 3 cos t's derivative is minus sin t I cap plus 3 sin t's derivative is cos t, 3 cos t j cap plus 4 t's derivative is 4 with respect to t, 4 k cap. So this is our tangent vector. Next we have to find the unit tangent vector. So to find the unit tangent vector, we have to find its magnitude, because your unit tangent vector is, let it be t cap. T cap is equal to t vector by its magnitude. So we have to find the unit tangent vector. Now the unit tangent vector, the magnitude of the tangent vector is square root of 3 minus sine t the whole square plus 3 cos t the whole square plus 4 square. Now the magnitude of the tangent vector is equal to square root of 9 sine square t plus 9 cos square t plus 16. Now when you take this 9 common, you will get inside the bracket sine square t plus cos square t. Now sine square t plus cos square t is 1. So inside the square root you will get 9 plus 16. Now 9 plus 16 is 25. So square root of 25 is 5. So this is the magnitude of the tangent vector. Now our tangent vector was minus 3 sine t I cap plus 3 cos t j cap plus 4 k cap. So our unit tangent vector is minus 3 by 5 sine t I cap plus 3 by 5 cos t j cap plus 4 by 5 k cap. This is the answer. Now our third question is, show that d by dt of box u vector du vector by dt d square u vector by dt square is equal to box u vector du vector by dt d cube u vector by dt cube. So we have learned a formula before, that is d by dt of box ABC equals box d by dt of A vector B vector C plus box A vector dB vector by dt plus C vector plus box A vector B vector dC vector by dt. Now this is the formula we are going to use here. So first we can take this LHS. This is our LHS. So first we are taking our LHS. D by dt of box u vector du vector by dt d square u vector by dt square equals, first we have to take the derivative of u vector, it is box du vector according to this formula, box du vector by dt. Now keep these two vectors as such, du vector by dt. Now d square u vector by dt square. Next I will write it here since there is no space, plus box u vector d square u vector by dt square. Keep this d square u vector by dt square as such, plus box u vector du vector by dt d cube u vector by dt cube. Now if you check these two terms will be 0. Why? Because the box product, in the box product two vectors are same. If in the box product two vectors are same, then the answer will be 0. that terms will be 0. Now du vector in this term, this is of the form a dot a cross b. Now these two vectors, when you take the cross product of these two vectors, you will get a vector which is perpendicular to the plane containing these two vectors. And when you dot that vector with du vector by dt, you will get the angle between these two vectors is 90 degrees. So you will get this term as 0. Now similarly here, here also the answer is this term is 0, because when you take this u vector dot d square u vector by dt square cross d square u vector by dt square, since these two vectors are same, you will get, when the cross product of two same vectors are taken, you will get it as 0. So this term will also be 0. So the remaining term will only be this term. So d by dt of box u vector du vector by dt d square u vector by dt square equals box u vector du vector by dt d cube u vector by dt cube. This was the relation we had to prove. So hence we proved the relation. LHS is equal to RHS. Hence proved. Our fourth question is, if dA vector by dt is equal to u vector cross a vector and dB vector by dt is equal to u vector cross b vector, then prove that d by dt of a vector cross b vector equals u vector cross a vector cross b vector. So we have to prove this relation. So first we will take this LHS. We'll expand this LHS and we will come to RHS. So our LHS is d by dt of a vector cross b vector. Now when you expand this, you will get a vector cross db vector by dt plus dA vector by dt cross b vector. So this we have learned in our formulas. Now we know what is dB vector and dB vector by dt and dA vector by dt. It's already given in the question. So we can write these two terms. So this is equal to a vector cross dB vector by dt is u vector cross b vector plus dA vector by dt is u vector cross a vector cross b vector. Now when you interchange this, for my easiness I am going to interchange these two vectors. So you will get a vector cross u vector cross b vector minus b vector cross u vector cross a vector. Now this is in the form a vector cross b vector cross c. We have learned this formula in our previous videos. So we can expand using that formula. We will get u vector times a vector dot b vector minus b vector times a vector dot u vector minus, when you expand this you will get minus u vector times b vector dot a vector plus a vector times b vector dot u vector. Now we can cancel out the same terms. See, when we look, this term is same as this term because A dot B is same as B dot A. So we can cancel out these two terms since they are opposite sign. So the remaining terms are A vector times B vector dot U vector minus B vector times A vector dot U vector. Now this can be written as like this, okay? A vector times U vector dot B vector minus B vector times U vector dot A vector. Now when you see this, we can write it in the form U vector cross A vector cross B vector. So this was our RHS. This is equal to our RHS. Hence we proved. So this was our last example. In the coming video, we will be doing some exercise problems. So that's all for today. Thank you.